All right, guys, so today we're starting chapter 3. This is a really important chapter. You got to know everything in this as best you can so that the rest of the year goes a lot easier for you. So try to pay attention, look for keywords that kind of help you form these equations, and be careful with your calculations. So today we're going to be talking about problems with constant rate of change. A rate of change is just another word for slope. So basically that's what we're going to be dealing with today. So number one, or situation one, says Stephanie Small weighs 97 pounds. She goes on an eating spree and gains 1/4 a pound per day. Now every one of these situations is going to have an initial value or a starting value, and it's going to have a change that happens per some time. So in this first one, the initial value is what weight she starts at, which is 97 pounds. Now, there's only one other number in there. That's going to be our rate of change. Note it says 1/4 a pound per day. That means every day she's gaining 1/4 more pounds. So I'm going to write rate of change is 1/4 per day. Now, if you'll remember how this setup goes, writing the expressions for how much she'll weigh after X days, number one, is going to be pretty easy. Now, first, we're going to write y equals, because we're actually writing something out to where we can find out how much she weighs on any given day. The first number you're going to write is going to be the initial value, wherever she started, so 97. This is the number that's set. It doesn't change problem to problem. Now what we're going to add to that is the plus her rate of change, but we don't know how many days we're talking about. Maybe it's 10 days, maybe it's 100, so that's our variable x. That's how many days. So now we have our expression y equals 97 plus 1/4 x. Now we have to answer a question about it. It says, how long will it take her to reach 160 pounds? Now I'm going to move down a little bit on this. But basically we're going to use the equation. I'll rewrite it so we have it in front of us. The equation was y equals 97 plus 1/4 x. And basically what it's asking is it's saying how long will it take her to reach 160 pounds? Well, you should know that this x is the number of days. So the only other variable we have is y. That's pounds. So the main thing we need to do, sorry pounds look so horrible. The main thing we need to do is make sure when it asks us a question that we're plugging it into the correct variable. Y is pounds, x is days. If it says how long will it take her to reach 160 pounds, we need to plug that in for y. So we get 160 for y equals our expression, 97 plus 1/4 x. Now we have to solve. Well, we've been doing this for a while. First, I'm going to subtract the number from both sides. 160 minus 97 gives me 63 equals the 97's cancel out to 0, and I have 1/4 x left on the other side. Now we need to clear our fraction by multiplying both sides by the denominator, which is 4. The 4 cancels out the 1/4, so I have x on the right. 4 times 63 gives me 252. Now, the solution is 252, but you have to make sure you're writing labels on these so you know what you're talking about. The solution is 252, but that's an x value, so that means it's going to take 252 days. And guys, these are all basically going to work exactly the same way. Be careful, use these on your homework. Let's go to the next one. Flotina is pedal boating on a lake. She starts back towards the dock, which is 800 yards away. She goes at a rate of 50 yards per minute. So let's go ahead and look for our initial value. She starts 800 yards away. So I'm going to put that that's our initial value. The change, again, has that word per. It's 50 per minute. And since we're talking about yards, I'm just going to go ahead and specify it's 50 yards per minute. Now this one's a little different than the last one. Again, it says write the equation for how far Flotina is from the dock after X minutes. So it's going to be y equals. We're still going to put our initial value, but you have to think logically. If we are going back towards something, our distance is getting smaller. So we're going to be subtracting. And in this case, we're going to be subtracting 50 yards per minute, but we don't know how many minutes it's going to take her. That's where our x comes. So Oh man, didn't mean to take that away, sorry. So now we have our equation, and I'll rewrite it there a second time, is y equals 800 minus 50x. So please keep in mind what y and x actually are. Y is our distance from the docks. X is our time in minutes. So now let's answer a question. It says, how long will it take Flotina to be 150 yards from the dock? Now, it's saying 150 yards, which is a distance, so we're going to plug it in for y. 150 equals 800 minus 50x. So now we can solve that just like we did on the last one. X is already pretty much by itself on one side, meaning there are no other x's. Let's move our numbers to the other side. So I'm going to subtract 800. 150 minus 800 is negative 650, and that equals negative 50x. Then our last thing is to undo the multiplication with division, so I divide by negative 50. Well, the 50s go away, and I get x equals negative 650 divided by negative 50 is positive 13. So I'm going to write my solution as 13, but again, I want to label, it's going to take her 13 minutes to get that far back to the dock. So, again, it's pretty much the same thing. One was subtraction, one was addition, but the work was pretty close to the same. Let's go to the next one. Situation 3. Olivia and Chad were at adjacent typewriters while practicing their typing. Don't worry about the word adjacent. It means they were next to each other typing. Olivia averages 45 words per minute, while Chad averages 30 words per minute. When Olivia is typing, Chad starts typing, Chad has already typed 90 words. Now this one is a little bit different because there's two different situations. Let's just talk about Olivia first. We need to know the initial values, how many words they've started with. Well, it says when she starts typing, Chad has 90 words. So Olivia's initial value is going to be 0, but that means Chad's initial value is the 90 that he already had typed. Now be careful on the rate of change. Olivia's rate was 45 words per minute. Chad's rate is 36 words per minute. So you can imagine at some point, even though Chad has a lead, since Olivia can type faster, she's going to end up catching up. So we do have two equations here. Now, when we go to write them, Olivia does not have an initial value, so we don't have to worry about the number. We do have a rate of change, though, which is going to be times x. We don't know how many minutes she's going to type for, but we do know she can type 45 words per minute. Now, Chad did have an initial value, so his equation's different. He started with 90 words when she was at 0, but then he types 36 words per minute. The reason it's addition is because we are adding to a total. We're getting more words as time goes by. So we need to answer a couple of questions about that. It said, after 5 minutes, how many words had each of them typed? Now, 5 minutes, that's going to be our x value, because in both of these, x is minutes. Y is the number of words. So I'm not going to plug it in for y this time. I'm going to plug it in for x. So I know that y equals 45x, but I also know what x is in this situation. It's 5. So Olivia's equation is y equals 45 times 5. 45 times 5 is 225 words. Now Chad, we're also going to be plugging in 5 for x, but his equation's different, so be careful. It's y equals 90, because he already had 90 words, plus the 36 words he can type per minute times 5 minutes. Then we just do 90 plus 36 times 5, and you get 270 words. Now, you don't have to write these in this particular order. I'm going to change colors here just so you know. This 90 plus 36x is the same as 36x plus 90. So I don't want you to be concerned on addition, because order does not really matter. It might help you out a little bit to write it the other way, because that's probably the way you've seen it before. Let's go to this last piece here. It says, how many minutes passed before Olivia typed the same amount of words as Chad? Well, this is a pretty good question for something we're going to do in the future. First, I know Olivia's equation, I'm going to write it up here, was y equals 45x. And I know that Chad's was y equals 36x plus 90. Well, I want to know when those equations, when the words they typed are exactly the same, meaning that y is the same as y. Well, guys, if y is equal to y, then the equations are also equal. If they are the same amount as what we're looking for, I set the equations equal to each other. So 45x equals 36x plus 90. So we've solved lots of equations that look like this. First, let's get our x's all on the same side. So I'm going to move my 36x to the other side through subtraction. Remember, we've been having trouble with this. We do it to one side and to the other only once. Well, 45x minus 36x is 9x. The 36x goes away on the right and leaves us 90. I then divide both sides by 9, and I found that x equals 10, but we have to know what that means. Our x values are minutes, so x equals 10 minutes. So after 10 minutes, they've typed exactly the same amount of words. She caught up to him in 10 minutes. So guys, this is not super complicated if you'll put your mind to it. If you need help, you've got to be coming and getting it, because this is really, really important, the things that we're going to do in the future. So if you need help, come get it, and good luck.